Hello, welcome back to my YouTube channel, and today we have to deal with this exercise concerning with Boolean Algebra. So Boolean Algebra laws, there are so many, so now let us apply some of them. You see, on our body here, we have question 1, state De Morgan's theorem, and then B, prove De Morgan's theorem. And then, second question, simplify the following. Fxy equal x plus y cross y cross x plus y. So now, I would like to request you to be with me until we finish. So now, the first one, De Morgan's theorem. De Morgan's theorem states that A cross B negation, meaning that this is A and B, negation is equivalent to this is A negation plus B negation. Now, this is A and B. So now, B states that A plus B negation, so this is A or B. Negation is equivalent to A negation cross B negation. So this is De Morgan's theorem. Laws state that A and B negation is equivalent to A negation plus B negation. So now here, A or B or A plus B negation is equivalent to A negation cross B negation. So now let us prove question. So this is about A. Here we can let us say this normally. Okay. So then B, let us prove that we can start from here. A and B, whether is equivalent to A plus B. So now, how can we prove this? By using trap table. By using trap table, we can show that here A and B negation is equivalent to A negation plus B negation. So now what to do? We have A input and B input. So now here we have 1, 0, 0, and we have 1, 0, 1, 0. So now A and B, this is 1 cross 1. You know that when we are calculating A and B, we know that we get true or we get 1 when both conditions are true, otherwise we get false. So now 1 cross 0 here, it is 0, 0 cross 1 is 0, and then 0 cross 0 is 0. So now A cross B not, it will be here, we have to invert this 0 into 1 and 1 into 0, meaning that here we have 0, then 1, 1, 1. So now, we want to compare, here we have A naught, and then B naught. So now, A plus B naught. So let us see whether this can work. Here we have 0, 0. Here we have 1, then 1. And B, we have 0, 1, 0, then 1. So now, A if we have A negation here and B negation. So meaning that A 0 plus 0 equal 0, 0 plus 1 equal 1, then 1 plus 0 equal 1, and then 1 plus 1 equal 1. So now let us see whether if we take this column here will be equal A negation. So you see, if we highlight this one here and this one, and highlight this one here, you see, sorry here, you are not okay, but here you see, this one, the value we have here is equivalent to two value we have here. So this is clear. So now, here, we conclude that A and B negation is equal to 2A negative plus B negative. So this is for this one. So let us verify whether this one is equivalent to this one. And now here, how have we called this? The second one, we have here A plus B dot, whether is equivalent to A cross B. So now, let us see if also this can be proven. Let us input A, input B. We have A plus B, and then A plus B naught. Here we have 1, 1, 0, 0. We have 1, 0, 1, 0, 1, 0 here. You see, A plus B, this is A or B. Even the computer science will say A or B. So now, A or B here, it gives us true when one of the conditions is true. Here. So now 1 plus 1 equal 1, 1 plus 0 equal 1, 0 plus 1 equal 1, and then 0 plus 0 equal 0. It means we get first when both inputs are first or when both conditions are first. Here. So now, negation of A or B, here we invert 0, we invert 1 into 0, meaning that we have 3 zeros here, then here we have 1. So now, we have also another column, we have A naught, then you have B naught. Here you see, here A naught is 0, 0, then 1, 1. Then here we have 1, 0, 0, 1. Then A naught cross B naught. Here it is equivalent to 2. So now here it is 0. Here it is 0 again. It is 0 again, then 1. So now let us verify whether A or B negation is equivalent to A cross B. So now, if we check it clearly, we can see that the value we have here, are similar as the value we have here. And then we conclude that here A plus B naught is equivalent to A. So now you see it is proved according to De Morgan's theorem here. So now you see the value you have here is equivalent to this one. So now, exercise number 2, by Boolean Algebra simplification, we have to simplify f, x, y, which is equivalent to x, x plus y dot y x plus here. So now, as mathematics, if we know that how to multiply this one, we can simplify this. First of all, let us bring this y out of here. So now, and you remember that multiplication is commutative. So now here we have square bracket x plus y close x plus y, and then to be enclosed in square bracket. So now here we have to say y square bracket x cross x. Here is x, then plus x plus y, not x plus y, x, y, then plus y cross x, then y cross y, here, like this. So now, we know that by identity laws of Boolean algebra, by algebra here. So, but here you see x, there is an equivalent to x. So, but here there is a small mistake here. Y cross y is equivalent to 2. Here we have to have double y. So now it means that we have y crossed by, here this x will produce 1x, x plus by using identity law, x plus xy, here you see. And now here, this y also, y will produce 1y. So now here, it means yx plus y, then close the square bracket. So now, here, let us do this. Y, here we can put x out of this parenthesis. We have here x. Then we have 1 plus y here. Then plus this y also can be out. Yx plus 1 here like this. So now you see, by using Boolean constant, state that a plus 1 equal 1. You see, if you have a here, a plus 1 is equivalent to x plus 1. So now it means here we have y square bracket x, meaning that here this will be equivalent to 1, and this will be equivalent to 1, and then here we have x plus 1. So now, to reach here, it is not necessary to use this square bracket. You can say yx plus y. So now, what to do? This y will be inside of a bracket, and then yx plus yy. So this is equivalent to here. This will give us 1y. Here you see x. Okay, so this will be yx plus y. You can put out y, and then y out x plus 1. So this is equivalent to 1 here. So now you can say this is equivalent to y. Finally, fx y is equivalent to x plus y here, x plus y. So now, after simplify, fx x plus y cross y, x plus y is equal to y. So now, this is how you can easily simplify Boolean algebra by using different laws. So now, I have to remind you that if you are interested in, never forget to give us subscribe, share, like, and comment. So, thanks.